Today we're going to be looking at radical equations and problem solving. Our first one has the square root of the quantity 3n minus 5 equals 4. In order to undo that radical sign, we're going to square it, since squaring is the opposite of the square root. What we do to one side of the equation, we have to do to the other, and we're left with 3n minus 5 on the left side and 16 on the right. Adding 5 to both sides, we end up with 3n equals 21. Dividing both sides by 3, we find our answer to be n equals 7. Solving our next example, we have the square root of the quantity 8x plus 5 plus 2x equals 0. We move that 2x over to the right side by subtracting 2x. Now we're going to square both sides, and when we do that, we find we have 8x plus 5 equals 4x squared. Taking the 8x and the plus 5 to the other side, we have 4x squared minus 8x minus 5. That factors quite nicely into 2x plus 1 times 2x minus 5. Setting each of those equal to 0, we take the 1 to the other side and we have negative 1, and dividing by 2 to get x by itself, we find that x equals a negative 1/2. The other part is 2x minus 5 equaling 0, and we take the 5 to the other side to get 5, and then we divide by 2, we have x equals 5/2. Our next example is the cube root of y plus 3 plus 7 equals 5. Well, we subtract the 7 to both sides, and we end up with the cube root of y plus 3 equaling a negative 2. So we cube both sides, and we end up getting y plus 3 equals a negative 8. Subtracting 3 to both sides, we find y is a negative 11. Our next example is the square root of 36 minus s equals s plus 6. Squaring both sides, we get 36 minus s equals s squared plus 12s plus 36. Combining like terms, we have a negative s equals s squared plus 12s. Taking the s over to the other side, we have s squared plus 13s equaling 0. Factoring an s out, we have s times s plus 13. Well, s could equal 0, which is here, or s plus 13 could equal 0, which would mean s is a negative 13. But we want to check our answers by plugging them in the original equation, and when we do that, we find out x equaling a negative 13 does not work, because the square root of 49 does not equal a negative 7. Our next example is the square root of x plus 1 plus the square root of x equals 5. Taking the square root of x over to the other side, we have the square root of x plus 1. Now we're going to square that, and it equals 5 minus the square root of x squared. So when we do that, those are opposite functions, so they simply go away, and we're left with x plus 1. When we go ahead and FOIL this, we have 25 minus 10 times the square root of x plus x. Starting to combine like terms, we take and we subtract the x's, they go away. We take this over to the other side, and we have 10 radical x, and we subtract 1, and we're left with 24 on the right side. In order to remove the radical, again, we square it since they're opposite functions, and we're left with 100x equaling 576. Dividing by 100, we have x equaling 576 divided by 100, which reduces to 144 over 25. Now we're going into the Pythagorean theorem for right triangles. It is a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse of the right triangle. In our example, if the legs of the triangle are 9 and 12, find the hypotenuse. Well, we simply plug it in the theorem. So we get 9 squared plus 12 squared equals c squared. 81 plus 144, and we know is 225, and that equals c squared. So now we're going to take the square root of both sides, and we end up with c equaling 15.